Welcome to day 4 of our factoring unit. This is the last day of new notes, and there actually isn't even a new factoring method here today. We are just going to be looking at some special cases for our quadratic trinomials. So that means we have 3 terms, highest exponent is 2. So the first special case that could happen here is we have a GCF, or a greatest common factor. So if you look at our trinomial, I have 2x squared plus 16x plus 14. Those can all be divided by 2. So they all have a common factor. So I would factor out that 2 first. And I'm left with x squared plus 8x plus 7. Now that I've factored out my 2, I need to factor this trinomial on the inside. I'm going to factor that the same way I always do. So you can do it either by grouping or by the box method, but they start the same way. I need to know what's going to multiply to a times c. So in this case, a is 1, c is 7, so multiply to 7, and add to b. b is 8. The only things that multiply to 7 are 1 and 7, and 1 plus 7 equals 8. If I factor this by grouping, I split my middle term. So I would have x squared. My new middle term is 1x and 7x. And this still has that 2 out in front. So now to factor by grouping, I look at each half. In my first half, the GCF is an x. So I'd be left with x plus 1. In my second group, my GCF is 7. I'm left with x plus 1. And this is still all being multiplied by that 2 on the outside. Now in here, I have a common factor of x plus 1. So I can factor that out. If I factor out x plus 1, I'm left with x plus 7. And this 2 still exists out there. So completely factored, I would have 2 times x plus 1 times x plus 7. In our second example, we have a typo. This should be 4x squared minus 1. Sorry about that. So in this case, the problem is that we have no middle term. There's no b. So we know when we are factoring, I need to find out what multiplies to a times c and adds to b. But I don't see a b in this case. So that means b is equal to 0. So really this trinomial is 4x squared plus 0x minus 1. So now a is 4, b is 0, c is negative 1. So if I'm looking for a times c, that's 4 times negative 1, or negative 4. I need that to add to 0. So some things that would multiply to negative 4. Well, if this is negative, 1 needs to be positive and 1 needs to be negative. So I could have 1 times negative 4, negative 1 times positive 4. Well, this adds up to negative 3. This adds to positive 3. Those don't work. I have 2 times negative 2. Oh, this works. 2 plus negative 2 would give me 0. So I know those are my 2 numbers on the side. If I factor this one using the box method, I know in my top left corner, I would have 4x squared. Bottom right corner, I would have negative 1. And I'm splitting my middle term into 2x and negative 2x. So if we start finding our GCF of each row, my GCF for 2x and 4x squared is 2x. My GCF for negative 2x and negative 1 is negative 1. GCF for 4x squared and 2x, well, that's also 2x. And here they both have a positive 1 in common. So in factored form, this would be 2x plus 1 2x minus 1. This is actually a super special case. We call this a difference of squares. So difference of squares means that in our original problem, these are both square numbers. 4 is 2 squared, 1 is 1 squared, and it's a difference of squares, meaning they're being subtracted. Whenever you have a difference of squares, you're always going to end up with basically the same thing in both binomials, but one is going to have a plus sign and one is going to have a minus sign. This pattern always happens like this. Our last two special cases. What if you have two identical factors? So there's nothing weird with the problem we're starting with. I don't have a GCF to factor out, and I have A, B, C visible in my problem. So I'm just going to factor this same way we always do. A times C would be 1 times 16. B is negative 8. So I need to multiply to 16 and add to negative 8. So what multiplies to 16? 1 times 16. 2 times 8. 4 times 4. Oh, 4 times 4, if I added those together, I would get positive 8. I need negative 8. So if I have negative 4 and negative 4, those would add to negative 8. So I know that's what these numbers are. So this is where our identical factors are going to come in. We ended up with the same number for our middle term. So if I do this one, let's do it by grouping. I'm splitting my middle term. So I have x squared. I'm splitting my middle term into negative 4x and negative 4x. If I group my first two terms together, x squared and 4x have an x that I can factor out. I'd end up with x minus 4. Negative 4x and 16 have, let's see, if I factor out a 4, I'm left with negative x and positive 4. Well, that's the opposite of what I have here. So I know I have to factor out a negative 4. So I get positive x and negative 4. So here's my common factor, x minus 4. When I factor out x minus 4, what I have left over is also x minus 4. So I could leave my answer like this, x minus 4 times x minus 4. But mathematicians like to write everything as concisely as possible. So we would really write this as x minus 4 squared. And we would say this trinomial is a perfect square trinomial. And it's called a perfect square because its two factors are the same thing. I can write it as factor squared. Our last case, what if the expression doesn't factor? So I don't have a GCF to pull out. I have A, B, and C. If I try to factor this, A times C, well, A times C is 4 times 1, that's 4. B is positive 1. So I need a pair of numbers that are going to multiply to 4 and add to 1. So numbers that multiply to 4 are 1 times 4, 2 times 2. I could do negative 1 and negative 4. I can do negative 2 and negative 2. None of these pairs are ever going to add to never going to add to 1. That means that I can't factor this expression, and I would say it is prime. It can't be factored. The only things that it can be divided by are 1 and itself. Your job is to try the 8 practice problems on the side, and then try some IXLs, and do your 2-question check-in.